Good morning or good afternoon, everyone, depending on where you're joining us from, and welcome to today's webinar. My name is Kyle from Business Review, an NS Media company, and I'll be your host today. It's our pleasure to have Donaldson Filtration with us, who is presenting this webinar entitled Medical Air Supply for Technical Application. Today's guest speakers are Wolfgang Bongart, Engineering Manager, Compressed Air Filtration, and Dave Taylor, Key Account Manager. I'd like to welcome you all to our webinar platform On24. You'll notice that this webinar is browser-based, so if you disconnect for any reason, please just click on the link you received by email to rejoin the session. If you want to ask any questions, you can send those in via the questions widget. Just type them into the box at the top left-hand corner of your screen, click submit, and we'll have some time at the very end to address any questions or thoughts that you may have. Please use the yellow help widget if you require any assistance, and you can move, resize, and maximize any of the windows in front of you to get a better view of the slides. But for now, please allow me to welcome Dave Taylor. Over to you, Dave.
Well, good morning, good afternoon, and good evening from whichever time zone you're calling in from today. Many thanks for joining this webinar on compressed air used within medical applications. The selection of correct filtration and purification for compressed air used for the operation of patient support equipment, the provision of breathing air, and supply for surgical tools and instruments is critical. As Carl mentioned, I'm joined by my colleague Wolfgang Bongart to carry out the presentation today. And as Carl mentioned also, any questions, please complete the information available. To begin with, I would like to provide a brief overview of the Donaldson Company. The company was formed in 1915 by Frank Donaldson and has now grown into a $2.7 billion company with 47 manufacturing plants worldwide. Our growth is based on the many diversified markets we work with and high levels of investment in research and development that ensures that Donaldson technology is always moving forward to meet the requirements of an ever-changing world. Donaldson Filtration is closely involved with many parts of our lives. Our integrated manufacturing from design and development of filter media to the final filtration system installed with the customer enables Donaldson to continuously grow and develop technology for all market applications. As previously mentioned, our products are used in many diversified applications, from the filters installed on farm equipment that is harvesting our food to food production companies where purification of sterile water and gases ensure extended shelf life. Donaldson filters are installed on mechanical diggers, cranes, and construction equipment, building our new homes and manufacturing plants, to then ensuring the air in the buildings is clean and comfortable for the employees. When you're traveling by plane, the recirculated air that you breathe may be filtered by Donaldson. The bottled water that you drink can be purified by Donaldson LifeTech range of liquid filters. Most importantly, Donaldson do not manufacture filter elements. Do not just manufacture filter elements. Through research and development, they invent and develop the filter material at the heart of the purification process. The continuous objective is to help our customers protect not only product and process integrity, but also ensure the people working within these applications are working in a safe environment. Donaldson is a technology-led filtration company with many, many strong customer relationships that have lasted a large proportion of our 105-year history. The diversified product and service portfolio allows us to access many different markets. Our global reach and local touch ensures that our customers receive a level of services and support wherever they are in the world. And our focus on innovation and new solutions means that we are always ready for the next challenges. At this point, I would like to hand you back to Kyle for a poll question.
Okay, thank you. It is now time for our first poll. So to everyone watching, take part, click one option, click submit, and wait for the next slide to view the live results. But the question is just real quick, did you know that Donaldson is offering medical air solutions? Yes or no? So I'm going to give everyone just a moment to click and answer that, and then we'll be moving on to the next slide. But I think that should be long enough, so let's see how this turned out. Okay, it's like a big majority for yes there. Is that what you expect to see?
Well, we're personally not knowing the exact makeup of the audience. It's difficult to judge. But what I would say is that it's good to see that our products are well known within the industry. And I would see that for the 70% who know us, or 80% that know us, the new technology will be presented today, enhancing the product range. For the remainder who don't know us, we will be providing a comprehensive review of the Donaldson portfolio. So we're fairly confident that everybody will get something from this. I would like to move on now to what is medical air. Medical air is the terminology for compressed air used within hospital applications that are or can be used with equipment in direct contact with patients. The raw material for medical compressed air is ambient air. Depending on the location of the hospital, which can range from busy city centres to more remote locations, the ambient air, when mixed with the potential contaminants from the compression process, can cause damage to equipment, and if used for breathing air, these contaminants can have major effects on health and well-being. Typically, what we see within applications is three main areas of uses. We're actually using the breathing air for ventilators, which have been very high profile over the last few months, particularly because of COVID-19. It can be used as a carrier gas also for anaesthetics before and during procedures, and also for surgical tools and instruments used in the operating theatres. As you would expect, there are standards for medical air. And as you can see, we have different standards for medical air regulated by different countries and individual bodies. Medical air in hospitals is considered as a medical product and falls under the pharmacopoeia regulations and ISO standards. Pharmacopoeia is a benchmark that Donaldson used for design of any equipment involved with medical air or hospital applications. You will notice that we've included on this slide a specification ISO 8573, which is for compressed air purity. This in itself is not a breathing air standard, but is well used within the industry to identify the quality of compressed air required for different applications. And we will speak about that in a little more detail shortly. So what are the standards for medical air? Is that you'll see on the left-hand side the constituents, and then we have the two pharmacopoeia regulations. The first line is for Europe, the second line is for the USA. You will see immediately within the O2 concentration that there is a larger range allowed in the USA. With regards to oil contamination, in Europe, the levels are clearly defined, whereas there is no definition within the US version. For the carbon monoxide, the US has a slightly higher allowance, and for CO2, carbon dioxide, that is again the same for both Europe and America. With regards to the water vapor content of the air, is that within Europe, the specification is for approximately minus 48 degrees C atmospheric dew point, whereas in the US, it's at minus 5 degrees C atmospheric dew point. With regards to sulfur dioxide, we have a higher concentration again allowed in the US, and the NO and NO2 concentrations are very similar with just a slightly higher allowance in the USA. What is interesting is that the European pharmacopoeia states that they have a requirement for particulates to meet class 2, according to the standard we mentioned earlier, ISO 8573-1. This specification is only used for surgical tools and instruments and does not apply to all applications within medical air. However, what we have is an overview of the particulate levels required by Class 2 air to the ISO 8573. So for Donaldson Filtration, we actually believe that although this is only normally specified for surgical tools and instruments, that we believe this level of particulate removal should be applied for all applications to remove the risk of blockage to instrumentation, local filters that may be installed to protect such items as ventilators. We now come on to the medical air purification system. These are the main components that we would expect to see within a medical air system. The first area is that, of course, we have a compressor to supply the power and energy for the operation of the equipment. The first stage would be a cyclone separator, which is a fairly basic form of filtration, removing bulk condensate and large particulates. It also acts as a safety precaution in case of failure of any of the drainage systems within the compressor itself. The next stage, as you can see, is the air receiver, where the air will be stored, and due to this storage time, the temperature will reduce, allowing further condensate to be removed from the compressed air. In addition, it will help with the control of the compressor. And then we would go into a pre-filter, which will be removing solid particles from the compressed air down to low levels, and the removal of water and oil aerosols. The next stage we've included is optional. This is a refrigerant dryer. This could not be installed by itself, as the quality on the outlet from the refrigerant dryer will not provide the levels required by pharmacopoeia. However, the benefits of installing a refrigerant dryer is that it will actually assist in improving the performance of the equipment further downstream by helping with removal of carbon dioxide and sulfur dioxide. The next stage is the absorption dryer, and this is the most important part of the system, excuse me, because it includes a pre and final filter to ensure the level of particulate is always meet as a minimum class 2. Secondly, we have an absorption dryer that will give us a pressure dew point of minus 40 degrees C, which is way above the actual requirements of pharmacopoeia. And we're also installing within this package activated carbon and catalyst material for the removal of CO, CO2, SO2 and NO2. And of course, the final filter will remove the particulates. Finally, on the outlet, we have the opportunity or option to install a sterile grade filter. The sterile grade filter can be used for two applications. The first is it will remove very fine particulate to better than class 1. The second is that if required, it will actually remove bacteria and virus from the system, and the element can be autoclaved to be able to maintain sterility of the filter element. We're going to look at the medical systems in more detail now, and I'll hand over to my colleague Wolfgang Bonger.
Yeah, thanks a lot, Dave, and also from my side, good morning, and good afternoon, and good evening, wherever you are, ladies and gentlemen. As Dave already mentioned, so I'm going to present a little bit more in detail the options we have here with our Donaldson portfolio to support finding the right purification solution for your application. And even if more than 80% are knowing Donaldson and even knowing that we are providing these kind of products for these applications, that might be interesting for you as well to see some new products here or even some hints what I would like to give due to our experience in that application. I would like to start here with some with some basic requirements of the ISO standards, especially the ISO 7396-1, which is requiring 3 independent sources of medical air supply. So that means that we have in a system where we only work with 2 compressors and 2 purification lines, we should have a third sort of source of medical air supply or medical air generation. In this case here, you see on the right corner here the air bottle set. So this is breathing air already provided in bottles, and in case of one compressor is in service, so is in maintenance, I mean, and the other one is running, and the compressor gets an issue, the running one, there is no compressor available, you can immediately switch over to the air bottle set, and then air from this bottle set is able to provide the required medical air supply. The most applicable and most frequently used system for in-house generation of breathing air or medical air is made by 3 compressors and 2 purification lines. And I would like to go a little bit deeper here in order to explain what are the benefits of this system. So first is a complete redundant purification system. So you have 2 purification lines and 3 compressors. That means, as I said before with the air bottle, the third compressor is always in place in case of the one compressor is in maintenance and the other one is running, and you get in trouble with this running compressor. What we can see also in the ISO 7396-1 is there is a requirement to have also a pressure dew point and CO measurement in place here. Also, usually there is a measurement of the oxygen level in the system. But especially on the pressure dew point and CO, you see immediately that something is not going correctly in the purification line. And therefore, you are finding in most of the application a so-called central control system that has 2 main functions. First, it's controlling the compressor running times and also the purification line running times, so that you have equal utilization of the compressors and the purification lines. But the most important thing, what it also does, is it's controlling and having alarm management. So there's a monitoring of these contaminations, like the pressure dew point, for instance, or the CO. And in case of an alarm, let's say on the top purification line, then it immediately switches over to the second line. And then the first line, in the meantime, can be serviced, or somebody can look if something else is going wrong in the system. So some hints when you are applying this kind of installation in your application. Normally, what you can find is that the air receiver tanks are located downstream the compressors, directly downstream the compressors. But it can be of high benefit to have an additional buffer tank at the end of, or the outlet of the purification lines. So first, the benefit is you have a large volume of already purified air available, which you can use directly. And then it is also acting in case of you have, for instance, a CO2 peak coming from the ambient air, and which the purification line, and especially the adsorption dryer system, cannot take immediately, and you have a slight peak at the outlet of your purification, then a large volume will lead to the fact that you have a mixture of high contents of CO2 and very low contents of CO2, and at the outlet you are just having an equal and only a little bit increased CO2 level, but there's not a big risk that you're exceeding the limit values. The same applies also to the oxygen concentration, what you can also find sometimes, and especially if you are looking at the very small range allowed from the pharmacopoeia between 20.4 and 21.4% of oxygen, some deviations in the system can lead to the fact that also your oxygen level is going at the edge of your of the tolerances or the limit values, and therefore also this buffer volume helps in order to keep the requirements. The other thing, and Dave mentioned that already, is if you have a refrigerant dryer in the system. So this is really best practice because it is not only reducing the overall water content in the purification line, which helps of course the adsorption dryer to be more efficient, but especially in areas where you have very high ambient temperature, let's say in Southeast Asia or somewhere else in hot ambient areas in the world. It has also the effect that at the outlet of a refrigerant dryer, the air temperature is in a range of 5 to 10 degrees C lower than the incoming temperature into the refrigerant dryer. And as I said, it helps also the adsorption dryer to improve the dew point performance. So the lower the inlet concentration of the water is, the better the performance of the dryer is. And this, in the end, helps also to improve the CO2 adsorption performance, because this is directly linked together, so that you can really say the lower the pressure dew point, the higher your CO2 retention efficiency is. And that's also interesting if you are running a dryer with a dew point control system. Then at the end of the dew point control, you should also always set your value when you are switching over from adsorption to the regeneration cycle as a relatively low value. So our recommendation is it should be in the range of minus 40 degrees pressure dew point or even lower. Having now a look into some details of our Donaldson portfolio for medical air purification. So in order to remove liquid oil and water aerosols and also solid particulates, we are usually working with coalescing filters, particulate filters or cyclone separators. So if we are working with coalescence filters, we are using our own technology. This is the ultra pleat technology from Donaldson, which is achieving very, very high retention efficiencies, especially for these liquids, at very low differential pressures. And we will see later on some figures on that in another application. So the second one, removing first, let's say, main portion of the water vapor, that can be done by a refrigerant dryer. And I would like to highlight here our Buran refrigerant dryer range already includes a pre and an after filter. So then in this case, it's not required to have some extra pre-filter in order to protect the refrigerant dryer. This is already included here. And this has of course some benefits for you as a user, because you do not need that high efforts for installing additional filters in your piping system. So the most important part of the purification system is the system which is removing the water vapor to a really, really low value, reducing the oil vapor the CO2, sulfur dioxide, and the nitrogen oxides. So this is usually done by adsorption dryers, and either in combination with an activated carbon adsorber system or as a compact breathing air unit. So both versions we have available with the UltraPack Smart product range and with the Ultra Pure ALGS system, which both I would like to introduce later on a little bit more in detail. And last but not least, important also for the application, the final filter, which is either only acting as a super efficient particulate filter, or if you are using that even as a sterile air filter, it is removing also bacteria. So in this case, we are working here with a PEG stainless steel filter housing and a PSFC sterile filter element. Having a look into the new UltraPack Smart dryer system. So if you are looking on the family, so this range can cover volume flows up to 100 meter cubes per hour with 10 sizes in between. So that means for your application, we have a nicely adapted range and the portfolio where you can find clearly your best solution in the range of air capacity for your in your system. If you're looking into the design and you see the picture in the middle, it's a very compact and lightweight design consisting of aluminum profiles and plastic material adsorber and filter structure. There is a pre and after filter already included to make it very, very compact. There's also a control system included, which is allowing you to have, for instance, the version with a dew point control, capacity control system. And there is also some other features which I would like to highlight. One specific one is kind of modularity. What you can see here on the picture is that you even can place the dryer in a horizontal position. This is not that frequently used in hospital and medical application, but maybe in some other application. But there are also some options to have the inlet and outlet connection into your air system, compressed air system, in different directions. That's also very applicable in many, many applications. It helps to reduce the efforts on your piping system. The other one is that we are working already with kind of connectivity in that unit. So we have an alarm contact available, which you can link into your central controller system. We have also available here a remote on-off switch where you can, from a central controller or from direct link to a compressor, running your adsorption dryer. For instance, only when a compressor is running, then the dryer is running and is consuming regeneration air for its own regeneration. That's also possible here. And if you are looking further into some features, we are using for the adsorbents not this bulk material of beads in an adsorber. So we are putting that, or we have made the design in a way that we are using cartridges where the material is filled in a specific way, and it is ensured that you always have the right quantity of adsorbent material inside of your cartridge, and with our quality securing system in our production, we are making sure that the weight of the material is always constant and is fulfilling the requirements here. Also, we are using here our DF filters with UltraPlea technology, and the good thing is that therefore we are highlighting here easy service. You can replace the filter elements and the cartridges all from the top of the unit. Yeah, so removing the top cover, and you have direct access then to the cartridges. And last but not least, That might be really an interesting feature also for medical and hospital application where very low noise levels are required, because usually these heatless adsorption dryers are generating a lot of noise when working. But we have found here a nice solution which we are calling ultra silencers. And if you are comparing that, if you look at the chart in the middle of the slide here, with the main most of the competitor solutions, these are working in a range of 70 to 90 dB noise level. And our solution here is achieving really a noise level of about only 60 dBA, which is really, really quiet, and sometimes even more quiet than the compressor or other equipment in the compressor room and even in the hospital. So that leads us to the fact that maybe we have a question for you guys.
Okay, thank you. So it's time for our second poll question. So to everyone watching, just like the last, just click one option, click submit, and wait for the next slide to view the live result. Our question is, how important is it for your work environment to have a silently operating absorption dryer? Very important, important, neutral, less important, or not important? Okay, so a few options there. So we're going to give everyone just a moment to think about that. But again, just click one option, click submit, and then we're going to move on to the results slide. Okay, but I think that's probably enough time. So let's move on and see how that turned out. Thank you to everyone who voted. That's like a majority there for important. Is that what you expect to see there?
Yes, I must say I find that it's interesting. I thought it would even be very important, especially in this application. But it's not only important for, let's say, a hospital application. If you are also looking into a lab environment where people are working directly in the environment of an adsorption dryer, that might be much more important than having that in the compressor room. So I understand why it is not always very important, because in the compressor room there is still some noise. But of course, if you have a system in there which is not generating more noise than already is in there, then it brings also a big benefit to the application and the user. All right, moving on with the UltraPAK Smart range. So our offering here for the medical air solution is that we are supplying a combination of the UltraPAK Smart Adsorption Dryer and the combination of a special adsorber module, and using here filters and cartridges for medical air treatment. So specific fillings here with activated carbon, with a special catalyst to remove the CO and a special molecular sieve to remove even further the SO2 and the NOx concentration. Also, we have to take into consideration that an after filter is already included here, and an oil indicator. And this is an oil indicator tube where you can easily identify if your activated carbon and your adsorbent material is still in a good condition and does not require service immediately. It is not foreseen to have that in place here as the real air quality measurement, which should be done downstream the entire purification line by a pharmacist or other people who are allowed to take these quality measurements. But as I said, it's a good indicator in order to quickly check if your adsorbent is in a very good condition. What I would like to mention also on the control system for the UltraPAK Smart is that we have here also 4 independent analog inputs, which is allowing you to place different sensors in your purification systems, like sensors for CO or for CO2 even, and you can indicate then these figures also on the touch display of the dryer. That's surely something which is applicable for this application and which is also helpful to reduce having other systems, indication systems in place here. Now we are coming to another solution based on another product. And I would like to highlight this here also as a best practice, what we have installed recently in a hospital in the Northern Europe countries somewhere. This is a system using 3 compressors and even 3 purification lines. And in addition to that, we are seeing here in the middle, this purification system is our ultra pure ALG. And in addition to that, as a backup, there is an additional activated carbon absorber, which is used in order to make sure that even at higher ambient conditions or higher concentrations of hydrocarbons and oil vapor, the system is always in a very good condition to capture that and to remove these high concentrations. So in addition to the activated carbon we have already in the system, there is as a backup an additional one for more reliability and more safety. And what we can see here also, there is sterile filters installed in that system as well. But I would like to highlight and focus a little bit more on the ultra pure ALG system as such. That means we have here 5 purification stages, where in the first oil and water aerosols and particulates are removed, and the oil aerosols are removed down to a level of 0.01 milligram per cubic meter. The pressure dew point, as already mentioned, down to minus 40 degrees C. This is also in accordance with the ISO 8573-1 class 2. So the CO2 is and the SO2 and NOx is below the limit values. And here, what we have to mention also, the residual oil content in this, after the third purification stage, which is removing hydrocarbons, oil vapors, and the SO2 and NOx. We see the residual oil content even below the required one of 0.1 milligram per cubic meter, but only at a level of 0.003 milligram per cubic meter. Yeah. In the fourth purification stage, we are removing then the CO down and far below the level what the pharmacopoeia and the ISO is requesting. In the beginning, when you are having new material, it's really 0, and it's not measurable at all. So in the last stage, we are having this particulate filter, removing particulates down to a level of class 1 to 2. It's depending a little bit on the operating conditions. If you are even are able to achieve the class 1 with the filters installed here. So if you are looking on this purification system, you are starting here with a 2-stage prefiltration using a microfilter type M here and a submicrofilter type S. I will come back to this in the next slide. And in the second part, you'll see the adsorption dryer consisting of the 2 adsorber vessels. Let's say the left one is drying, the right one is regenerating. And then on the stages 5 and 6, you have the first in one vessel an activated carbon material, and then with mentioned here with OX, this is the CO catalyst. And as the last stage, we are seeing here the particulate filter. Okay. If you're looking on the ultra-pleat filters and here on the microfilter stage, you see here the oil retention efficiency is about 99.4%. And if you are looking on the S sub-microfilter, you see oil retention efficiency of 99.9%. You can imagine if you have both in a row, then there's almost nothing left as liquid aerosols, either oil and water. Particulate retention is more interesting than for the after filter. This is also measured and validated according to the ISO, specific ISO standard here. And you see in the range of 0.2 micron, we are achieving here retention efficiencies of about 99.979%, which is very high in order to achieve also the class 1 in your application. All right, then I would like to hand over again to Dave.
Thank you very much, Wolfgang. Just following on from Wolfgang's presentation, we actually have pictures of the example that Wolfgang spoke about earlier in the presentation, where we have installed the 3 systems which are given a situation of lead, standby, and spare capacity. In addition to this, everything is designed in accordance with ISO and the EU Pharmacopoeia. The air is actually supplied by a lubricated air compressor, so there is oil being added to the compressor. So on this occasion, this is a very good reason to add the additional activated carbon tower that you can see to the right of the white cabinet in the picture. Also within this system, we have sensors, alarms and indicators fitted for oil carryover, dew point. We have a low pressure alarm, a carbon monoxide sensor and an O2 sensor, thus giving full protection and immediate information for the hospital maintenance team. On the right-hand side, you can see the final filtration arrangement. All of the pipework was done in stainless steel, and the 2 filters that you see are installed after the final regulator. The filter housings, these are 316 stainless steel and are based on our sanitary quality range. So that's a high level of surface finish to ensure a very high quality level. The elements installed will actually, as Wolfgang said, can either be used as a very fine particulate filter down to class 1, which of course is exceeding the pharmacopoeia regulations, and also as a bacteria removal filter, as the elements within here from our PSRFC sterile element range are actually suitable to be autoclaved to maintain their sterility. So this application really is doing its utmost to protect any particulate moving into the main hospital compressed air system. We'd like to just raise a couple of other points that you may come across, is that a lot of hospitals, as mentioned, will have a medical gas supply for oxygen. And what we have seen, due to the strong oxidative properties of oxygen, that hospitals have found a high degree of suspended particles in their oxygen supply. This has proved problematical for a number of installations. However, we have a product called the P-SRFO, which is a sterile filter element that's designed to work with oxygen, and the housing is suitable for use with oxygen, and this will provide us with particulate removal down to 0.2 micron with an efficiency, as you can see there, of 99.99998%. So for this sort of application, we can also provide a solution. Finally, not all the hospital air required will actually be used for ventilators and for patients and for surgical tools. There are other applications within a hospital. So typically, we are normally looking at 2 purity levels that could be required. This will depend on, number 1, the application, and number 2, potentially external pipework outside the main hospital buildings. Looking at the bottom system, where we see the refrigerant dryer, this system would be very suitable for things such as workshops, vehicle maintenance, general compressed air usage, and will give you a quality for water of basically class 4, which is a +3 degrees C pressure dew point, and oil and particulate. Oil is class 1, and particulate is class 2. So it's a very high level and high quality compressed air, even for what can be quite a basic application. Should the application be for laboratories, we may want to improve the quality of air, particularly for the water vapor, by going to class 2, where we would actually install the smart type absorption dryer, and that would be followed by an activated carbon tower to make sure that we have a completely oil-free and particle-free system in use. Just to let you know that as we're coming towards the end of the presentation, is that we do have the medical air literature, a new brochure that's just been made available. This is obviously available from Donaldson, and I believe will be available on the website shortly. And it covers a lot of the subjects we've spoken about during today's presentation. For further information, if you have any questions or any requests, please contact marketing@donaldson.com by email, and they'll be pleased to help you out. For general further information, please watch us on YouTube. We have a number of videos covering a wide range of the Donaldson equipment and applications. You can follow us on LinkedIn, and for further information, please visit our website at www.donaldson.com. I'm now pleased to pass you back to Kyle for questions.
Thank you. So it's now time for the Q&A portion. So at the beginning, if you want to take part, just type your question into the box in the top left-hand corner of your screen, click submit, and then wait to hear if your question is read out now. Well, we had quite a few come in over the course of the webinar, so we're just going to get started with, can we alternatively to the presented activated carbon absorber use activated carbon filters?
Yeah, I think that's a question I can answer. So activated carbon filters, you have not seen that here in the presentation because from our standpoint, only the activated carbon absorbers are bringing the right level of reliability in the system, because we have to look at the fact that the amount of activated carbon in an activated carbon absorber is much higher than in the filtration system. That covers two things. So first, the lifetime of the activated carbon stage is much longer than on a filter. And it gives also a little bit more reliability in order you have fluctuating operating conditions, and especially temperature, because the oil vapor content is directly linked to the temperature, and there is an expansional relation of the oil vapor content and the temperature. So it gives more reliability, and therefore we would not recommend to go with activated carbon filters but only with these absorbers. Thanks for the question.
Okay. No problem. Thank you. Next question is, in which service intervals is it required to change replacement parts?
Yeah, it's so our concept of having service is based on the fact that we have some components in there which should be replaced annually. Therefore, we have defined so-called service kits, annual service kits, which are normally including the filter elements, wear parts for the valves, also a condensate drain if applicable. For instance, in the absorption dryer, we have one in there. And then we have different kind of so-called care packs. And the care packs is consisting of a service kit plus the adsorbent material. And then depending on the solution you are working with, so in terms of the UltraPack Smart range, these are the cartridges. And the cartridges have to be replaced every 2 years. And in terms of the Ultra Pure ALG system, the service interval for the desiccants is every 3 years. What we strongly recommend is that also on an annual basis, you should replace the activated carbon and the catalyst material. So therefore, we have also created a care pack for an annual service of these adsorbers.
Okay, very good.
Okay.
I got a question here asking, which volume flow can you cover with your medical product portfolio?
Yeah, on the UltraPack Smart, the range is covering volume flows up to 100 meter cubes per hour. The ALG S range, so the UltraPure range, is covering up to 375 meter cubes per hour as a standard. But higher flows, we can also provide solutions on demand. So on project basis, we have done already some other volume flows, higher volume flows if required.
Okay, thank you. Someone here is asking how to choose the right dryer type of capacity.
How to choose it? For instance, in the technical data sheets, you can find also hints how to size a dryer, but also our sales representatives in the field can help you to determine the right solution. You cannot really say it's only there is one solution available. So sometimes it can be worth to look into different solutions. But there are clear sizing rules how to size an adsorption dryer depending on the flow, on the pressure, and on the temperature. Yeah. But then, in order to look if we are better using an UltraPack Smart system or an UltraPure ALG system, that can be decided case by case, or should be decided case by case by having all the effects and operating conditions and parameters on the table.
All right, very good. I've got a question here asking, what is the recommended interval for sterilizing the PSRFC element in an autoclave, more specifically in a hospital, medical breathing air application, such as monthly?
Dave, maybe you can answer this question.
Yeah, hi Wolfgang. Sorry, can you repeat that again, Carl, please?
Yep. What is the recommended interval for sterilizing the PSRFC element in an autoclave, more specifically in a hospital application?
Okay, is that with the sterilization of these type of filters, it will very much depend on the ambient conditions and the conditions that the compressor is working in. Obviously, we are providing very clean, dry air to the sterile filter, and the amount of humidity in the air will not allow any growth of bacteria. So, in many cases, there's a little bit of sometimes trial and error in it, and you might start by sterilizing once a month and then extend it to perhaps once every 2 months, and then you can start to get a feel for it. But I would start with probably at least a minimum of once a month until you find a safety point. But this would be done in line with whatever the hospital pharmacist's requirements are.
Okay, very nice. I think that might be all the time we have for today, which just leaves a big thanks to both presenters and, of course, to Donaldson Filtration for sponsoring this session. But to everyone watching, you will be receiving an email shortly letting you know how to access the on-demand version of this webinar. Or you can always watch it through our website, which is www.business-review-webinars.com. We look forward to sharing further webinars with you, so please do keep an eye on the website just mentioned. And follow us on Twitter at BL Webinars, Daily Updates, and join our LinkedIn group, Business Review Webinars. Thank you all once again, and I hope everyone enjoys the rest of their day.